This video is going to focus on calculating interquartile range. So first of all, let's just define what we mean by interquartile range. Well, inter just means between, quartile means quarters, and range just means distance. We've already seen range mentioned in statistics. And we've calculated it as highest value minus lowest value, so it's just the distance between the highest and lowest values in your data. Interquartile range is just the distance between the highest and lowest quarters of your data. And we call these Q3 for the highest quarter and Q1 for the lowest quarter. And this is our calculation for interquartile range. And at this point, I'd like to just introduce an abbreviation for interquartile range. We can call it IQR, and I'll be using that abbreviation from now on. So let's have a think for a moment what we actually mean by Q3 and Q1. Let's imagine that this line represents my data set, and the beginning of the line is the start of the data set, and the end of the line is the end of the data set. So my lowest and my highest values. Q1 will occur quarter way up my data set. So here I've marked a point a quarter way up the data. This Q1 occurs after the first 25% of the data. So again, that's just me saying a quarter way up in another way. We're 25% of the way up through our list of data. Q3 occurs 3/4 way up the data. So up until that point, we've passed 75% of our data, and this section here just represents the top 25% of our data. Here I'm calling these things Q1 and Q3, but just be aware these can be called the first quartile and the third quartile, or the lower quartile and the upper quartile also. So this gap between Q1 and Q3 represents the middle 50% of my data. And what the interquartile range is effectively measuring is how spread out that middle 50% is. How far is it from Q1 up to Q3? An interesting note at this point is that we've actually dealt with Q2 already, although we don't tend to call it Q2. Pause the video for a second. Think about where Q2 would be located on this scale. And can you think of another word that might be more commonly used to refer to it? So Q2 is 2/4 way up the data, and 2/4 is just a half, so it's halfway up. So what piece of information is halfway up our data? And Q2 could also be called the median. Like I said, we don't tend to call the median Q2, but it's just interesting to note that while we're looking at this diagram. In any case, for interquartile range, Q3 and Q1 are our focus. So here's an example. I've got a list of ordered data, and I want to find the interquartile range. Now, it's just important to note that if my data set wasn't ordered at the start of the question, I would have to begin by doing that. Now, I know that IQR, the interquartile range, is calculated by saying Q3 minus Q1. So I'll have to begin by working out Q3 and Q1. And this process is very similar to the process by which we find the median. So the first thing I have to do is I have to figure out how far up my data I would have to go to get to Q1. Now, if you recall, for the median, that was n+1/2. Now, if we want to go a quarter way up, how might you change that formula? Pause the video for a moment, have a think about it, and when you've done that, then unpause and see if you're correct. So Q1 is located at n+1/4, and it's 4 this time because I want to go quarter way up. So I need to go back to my data set and just check what n is. And when I count the number of data points, I find that n is equal to 11. So I'll fill that in and get 11 + 1/4, and I'll work that out, and my answer comes out as 3. Now, it's really important here. This is not the value of Q1. This is the position of Q1 on the list. So in this case, what that 3 really means is that I'm looking at the third piece of data. So I go to my list and I count 3 spaces up, and I see that my third piece of data is 16. This is Q1. Now that I have Q1, I have to find Q3 also. Now, Q3 is 3/4 way up the list. So the formula that I would use this time is 3 times n plus 1 over 4. And the reason for this is because 3 over 4 is 3/4. So again, I'll just fill my n in, and don't forget is 11. And I'll evaluate this, and I'll get 9. But again, just watch out, it doesn't mean that 9 is Q3, 9 is where Q3 is. It's the 9th piece of data. So just like before, I'll go through my data set and I'll go as far as the 9th piece of data. 1, 2, 3, 4, 5, 6, 7, 8, 9. 24 is where I land, and that's Q3. So now I have Q1, which is 16, and Q3, which is 24. And I can go ahead now and find the interquartile range. So don't forget, the interquartile range is Q3 minus Q1. Q3 is 24, Q1 is 16. And when I evaluate this, I get a value of 8. So this tells me that the middle 50% of my data spans 8 units. Just going back to my original data set, just to make an observation, that in my original data set, I had an outlier of 1. And one of the useful effects of interquartile range is that it chops off the bottom quarter and the top quarter of your data, which is where the outliers are going to be located. Here's a second example. Again, I've got an ordered data set, and again, just watch out if your data set isn't ordered at the beginning. That's the very first thing you should do. But mine is, so we'll start from that. We want to find the interquartile range. So that means I'm going to have to find Q3 and Q1 and subtract them. I'm going to start by noting how many data points I have, because I know that I'll need that to find where Q3 and Q1 are located. And in this example, n is equal to 16. So now I'm going to use that information to locate Q1. Remember, Q1 is located at n plus 1 over 4, which in this case is 16 plus 1 over 4, which means I'm looking at the 4.25th piece of data. We ran into a similar issue back in calculating the median, when we sometimes would get a decimal point at the end of our location, because obviously there isn't a 4.25th piece of data. So we're going to take the same approach we took with median, which is just to take the values either side of this, the 4th and the 5th pieces of data, and average them. So I'll go to my list and locate those two values. And my 4th and 5th values are 8 and 10. So I'm going to add 8 and 10 and divide by 2. And in this case, Q1 is going to be 9. Then I'll go on to calculate Q3, first of all, by finding its location. And I'll find its location using 3 times n plus 1 over 4. You must make sure to know these two formulae. And filling in 16, that's going to bring me to the 12.75th piece of data. But like before, there is no 12.75th piece of data, so instead I'll hit the 12th and 13th and average those. And that's going to give me 15.5. Finally, I'm going to calculate the interquartile range. And of course, don't forget, interquartile range is Q3 minus Q1. And in this case, Q3 is 15.5 and Q1 is 9. So when I subtract the two of those, I'm going to have an interquartile range in this case of 6.5.